Okay, welcome to Chapter 6, Part 2. So let's talk a little bit about remembering. When you're retrieving some memories from long-term memory, the target memory is what you're trying to remember. And what helps you remember is something called a retrieval cue. It's information that is learned along with the target memory, or you make associations between a cue and a target memory. And so if you are exposed to the cue, then it's easier to remember the target memory. And what you want, the idea, which I hinted at before, is you want encoding specificity. You want unique links between retrieval cues and target memories, and that makes it really easy to remember. So here's an example. Let's say you have the word happy that you're trying to remember, but you forgot what the word was. All of these words here link in your brain with happy. They make some kind of meaningful relationship with happy in the brain. And so any one can be used as a cue for happy. And having many cues might make it easier to remember. But again, remember, if there is one unique cue associated with something, sometimes it's much easier to remember that target. So again, Abraham and Lincoln are very uniquely associated with each other, and therefore one is a very potent cue for the other. So have you ever run into somebody that you thought you should remember, but you didn't? For example, you had class with them every single day, and then you ran into them somewhere else in the city, not at York College, and you just had, you can place a face, but you can't remember the name. Why in the world do you think this happens? Um, well, context and spatial location provide many cues for retrieval. So while you're in the classroom with somebody, you're so used to that person being at school that you make a very close association with them being at school, but you don't remember them in other contexts. And so without the appropriate cue, it becomes difficult to remember their name. This is an example of state-dependent learning. So the context and the environment is very important for making the associations. It's part of learning associations between cues and target memories. Um, But not only is it the environment of the context, but also the emotional and physical state of the person who's doing the remembering. So if you are under the influence of medication or alcohol or something and you learn a bunch of information, it becomes easier to remember that information if you're in the same physical state under the same drug. I don't recommend you start taking alcohol to study for exams. It actually do quite deteriorate, affects your performance, but there are several examples from anesthesia, um, post-traumatic stress disorder, and indeed a famous patient, HM, where if these if somebody was allowed to learn while they were under anesthesia, they would be more likely to recall that learning if they were in a similar state. Um, and similarly, a patient, HM, even though he had difficulty learning because he had brain damage, he could remember some things if he was exposed to the same context. Um, Post-traumatic stress disorder I use as an example because the problem, take a combat veteran. The problem with post-traumatic stress disorder is there are many environmental cues that they are sensitive to, that they remember from combat. So, for example, they're walking down the street, they hear a loud bang, and they might hit the deck or run for cover, or just have feelings of anxiety because that loud noise reminds them of the cues of combat, where they learned so many difficult emotional experiences. And here is a more experimental approach to that idea. So you could have people who are studying a number of words, and you have them study on land versus studying underwater, and you can test them on water or test them on land, and you find that people will recall more when they are tested in the same environment as the learning phase. So I think a good example of state-dependent learning. Um, Again, encoding specificity is very important, but you can have other problems. That's like encoding specificity is a good thing, of course. There are problems, though, with relating cues to target. You can have something called cue overload when you have too many targets associated with the cue. So, for example, what's your York password? Well, you may have many, many passwords. I'm asking you, the cue that I'm asking you is the word password, but you have so many targets associated with that cue that it might be difficult to retrieve that one individual target that you're looking for, which is the York password. So for example, the cue, email password, might be simple, but you might have either one target or you might have many, many, many targets. And the more targets you have, the harder it's going to be. And that's why you get this cue overload. I guess a similar example would be if I asked you, for the last name of one of your friends named John. If you know a lot of Johns, it's hard to remember the last name because there's so many targets associated with that unique, or with that cue John, unlike Abraham Lincoln, where there's a very strong degree of encoding specificity. And you can also have the fan effect, which is too many nodes between the cue and the target. So what the fan effect is imagine trying to remember what your boyfriend or girlfriend's favorite cake is. You know so many things about him, but there is no direct link between boyfriend and cake. Maybe you know everything but the favorite cake. Maybe you're never exposed to that knowledge, or maybe just once. There might be direct links between boyfriend and he likes dessert, so you know he likes dessert, and you know he likes chocolate, so it's a pretty safe assumption he likes chocolate cake. So you know he loves dessert, but he also loves hockey. So you know he loves chocolate. You know he hates vanilla. So it's a pretty safe assumption to say he likes chocolate cake. But the point I'm trying to get across here is that sometimes the relationship between the cue and the target, boyfriend and chocolate cake, have many links in between them. And it's not necessarily a direct link, which might make it difficult to retrieve that memory. And that's called the fan effect. And there also, of course, the effect of time. Now, time is not always our enemy in memorizing things. We always associate, the decay theory states that if you don't rehearse something, you will forget it. But spacing can also be a good thing. So we remember more if there's a period of time where memories can consolidate with cues. So if you take a nap in the middle of the day, or you sleep, or you take breaks while you're studying, this is actually a good thing because your brain has a chance to form those biological links between targets and cues. And we call this directed forgetting. You can intentionally relieve the fan and cue overload effects by taking a break while you study. And this is one of the reasons why cramming is such a bad idea for an exam. Cramming for an exam, sure, you might be spending the same amount of time studying and you might be exposing yourself to the same information, but you're doing it all in one lump and your brain really doesn't have a chance to catch up. It doesn't have enough time to make those associations between cues and targets. So a well-placed 20-minute nap is a good idea. Science has shown that it is as good and as effective as a full night's sleep. With regarding certain memory tasks and certain attention-based tasks. We don't say nap instead of sleep because sleep is very important, but it can have benefits for learning if you take a nap. So there is another view. When I originally started this chapter, we reviewed the memory systems view. So the memory systems view states that there's a modular level hierarchy of memorizing things that goes from perceptual memory to short-term memory to long-term memory. But there's also the levels of processing view. And it argues that there's only one type of memory. And it says that deeper, more meaningful encoding experiences lead to better retrieval. So the more you practice or learn something, that's the more likely you are to retrieve that information. However, the definition of deeper processing is not entirely clear. And the data doesn't support this model. It seems to be inconsistent with that model. Sometimes acoustic information is remembered better than semantic information. And semantic information has a lot of meaning, but it might be actually difficult to recall that information. So getting deeply acquainted with material doesn't necessarily mean that you're going to be able to recall it better. Some information is just easier to recall. So, and it doesn't seem to, for many other reasons, it doesn't seem to line up with what we know about the brain, but we did learn that the more times you learn something in a different context, the better retrieval is. So learning the same thing, the reason we have labs and all sorts of work in this class It's not because I just want to give you a lot of work. It's because if you learn the same information in different contexts, you're more likely to recall that information because you have more cues for retrieval. Um, Here is a cartoon for the levels of processing view in case you want to go back and review it, going from very superficial, shallow perceptual aspects of learning something about a particular person to more deeper aspects. The more you know about that person, presumably the more you would be able to recall information about that person, but it just doesn't seem to be entirely true. It's more about the number of cues that relate to information rather than the depth of learning. So once a memory is encoded, how does the information change when you try and recall that information? There are cases when memories we try to recall get subject to error. We call this confabulation, where we create a false memory. It's not that word lying. Lying is different from confabulation. Confabulation means you're not intentionally trying to lie, but you're creating a false memory because of your inability to remember things accurately. People tend to simplify history. When you go back and you think about maybe the first time you learned how to ride a bike, um, you might create actually some memories that are inconsistent with the actual story. Go ahead and ask your parents about some early experience you had and see if it agrees with your memory. Most of us try to create scenarios that make logical sense when we're remembering something from an early age. We want to have our memories make sense. We want them to agree with our schemas, our schemata. And a schema is, again, a notion for how the world works. So we have a notion of how the world works, we add a memory to that notion, and sometimes we have to alter that memory to fit with our schema of how the world works. If there are any inconsistencies, we tend to overlook those inconsistencies, and that's where confabulation occurs. Incidentally, that's a particularly important thing to study for psych and the law, because particularly with children, their ability to recall testimony and give testimony and recall facts on the witness stand is really highly variable. They're not very, very good at it, and they confabulate a lot. Other areas of memory that I'm not going to go into very deeply: autobiographical memories, memories about the self. We're slightly better at recalling stuff that pertains to us rather than non-autobiographical information. Flashbulb memories are very strong emotional memories that can be encoded deeply upon one presentation. So some people cite, when I ask students about a very salient memory in their life, a lot of them say 9/11. It was something that was burned in their minds forever. It's supposed to be more robust, but when you test it thoroughly, retrieval's not actually better for these memories than other non-trivial memories. Our confidence tends to be higher in flashbulb memories. And if you look back at 9/11 as the example, what's actually going on is you're being re-exposed to 9/11 again and again through the media, so there's a lot of rehearsal going on. You're getting subjected to a lot of cues. It's not actually a flashbulb memory. Eyewitness memory we just talked about. It's a very fallible process. The nature of the questioning bias is retrieval. When a person asks you a question a particular way, it sort of leads the witness to give a particular response, as though the act of retrieving information can manipulate the information itself. So in courts, they tend to adopt more statistical procedures to determine whether a witness is accurate or is lying or confabulating. And this is just a quick chart to show witnesses' belief about their own testimony over time, confidence versus accuracy, and their confidence increases the more time passes. All right, I'm going to stop right there, and we'll continue with the next section.